The most pervasive and stubborn misconception about electricity, which the great physicist Richard Feynman spent considerable effort dismantling, is the notion that electrical energy flows inside wires like water through a pipe. This intuitive but profoundly incorrect picture leads to a cascade of errors in understanding how circuits truly work. As Feynman eloquently explained in his legendary Lectures on Physics, the energy that powers our bulbs and motors does not travel through the wires themselves. Instead, it propagates in the space around the wires, carried by invisible electromagnetic fields. The wires, far from being conduits of energy, are merely guides, or as Feynman put it, leaky pipes that shape and direct this external flow of power. To grasp this, one must first confront the limitations of the common electron drift model. It is true that electrons, nudged by an electric field, do drift slowly through a metallic conductor. This drift velocity is astonishingly sluggish, on the order of millimeters per hour. If electrical energy were carried by these electrons kinetically, like bullets, turning on a light switch at the end of a long circuit would involve a wait of hours for the first electron to arrive. Instead, the bulb lights up almost instantaneously because the signal to start moving is transmitted at nearly the speed of light, not by the electrons themselves, but by the electromagnetic field established in the circuit. The electrons are more like a chain of marbles already packed in a tube. When you push one in at one end, another almost immediately moves out at the other. The marbles, electrons, move slowly, but the impulse travels rapidly along the chain. However, even this analogy is incomplete, for it still suggests the energy is in the chain. Feynman directs us to consider a simple circuit, a battery connected to a light bulb by two parallel wires. When the switch is closed, the battery does not pump electrons that then scurry to the bulb, depositing their energy like couriers. Instead, the battery acts as an energy elevator, lifting charges against an electric field and creating a voltage difference. This establishes an electric field between the wires, from the positive to the negative terminal. Crucially, as the electrons begin their slow drift, their acceleration generates a complementary magnetic field that encircles the wire, as described by Ampere's law. The interplay of these two fields, the electric field pointing between the wires and the magnetic field circling them, creates an electromagnetic wavefront, a pulse of energy described by the pointing vector. The pointing vector, S equals E cross B over mu naught, mathematically defines the direction and magnitude of energy flow. In our two-wire circuit, the electric field, E, points from the positive wire to the negative wire. The magnetic field, B, forms concentric circles around each wire. When you compute the cross product, a remarkable result emerges. The pointing vector points perpendicularly inward from the space surrounding the wires, converging on the resistor or light bulb. The energy flows radially inward from the empty space around the circuit, funneling into the bulb where it is converted to light and heat. The wires are essentially the banks of this energy river, defining its path but not containing its flow. In a coaxial cable, this confinement is perfect. The energy flows entirely in the dielectric between the inner and outer conductor, completely absent from the wires themselves. Feynman illustrated this with a brilliant thought experiment. Imagine a gigantic capacitor being charged by wires stretching across a vast distance. The wires carry a current, but between the plates of the capacitor there is a vacuum. No electrons can cross. Where then is the energy flowing as the capacitor charges? The electron flow model stumbles here. The field explanation triumphs. Between the plates, a changing electric field generates a displacement current, which in turn produces a magnetic field. The pointing vector shows energy flowing from the distant power source, not along the wires, but through the empty space around them, finally diving into the gap between the capacitor plates to be stored in the electric field there. The wires are essentially the islands of this energy river, defining its path but not receiving its flow. This misconception has real-world consequences. It explains why we can have wireless transmission of energy, as in radio or phone charging. The electromagnetic fields are the essential vehicle, and we are simply coupling devices to them. It clarifies why high-frequency signals in circuits experience skin effect, where current flows only on the outer surface of a wire. The energy is trying to travel in the space outside, so the interior of the wire becomes irrelevant.
It even demystifies why cables have specific geometries and shielding to control the external fields that are the true carriers of power and information. The deepest insight Feynman offered is that we live in a field-dominated universe. The fundamental entities in electromagnetism are the electric and magnetic fields. The charges and currents are sources that generate these fields, and the fields then interact with other charges, delivering forces and energy. To say electricity flows in wires is like saying the image flows in the cable for a television. It confuses the signal carrier with the information carrier. The wires are a carefully constructed guide for an electromagnetic wave, just as a fiber optic strand is a guide for a light wave. Overcoming this misconception requires a profound shift from a substance-based view of electricity, a thing that moves, to an interaction-based view of energy transfer, a dynamic process mediated by fields. It's a leap from the mechanics of the 19th century to the field theory of the 20th. As Feynman famously quipped, it's one of the most difficult leaps in physics education because it fights against our deepest intuitions. Yet embracing this truth reveals the elegant, invisible architecture of our technological world, where energy sails silently through the empty spaces around us, directed not by solid conduits, but by the elegant, invisible lines of force, first imagined by Faraday and codified by Maxwell. The wires are just the trellis. The electromagnetic field is the vine that bears the fruit of power.